In this question, we have to solve the quadratic inequality x squared take away x take away 12 is less than 0. Now the first thing we're going to do here is find the critical values, and that is done by putting this quadratic equal to 0. So we have to find the critical values. We're going to let the quadratic x squared take away x take away 12 be equal to 0. So now we're going to solve this quadratic. So I'll find my factors of 12. So that'll be 12 by 1, 6 by 2, and 3 by 4. Now we'll see which one of these, when we add or subtract, we will get this middle term here, which is negative 1. So this negative x means negative 1x. So 12 and 1 could never give you negative 1 if you add or subtract. Likewise, 6 and 2 could never give you 1. But 3 and 4, you can get 1. Now we want to get negative 1. So we'll say 3 take away 4. So just remember, 1 is understood to be in front of this x. So I'll open my brackets, put x. I'll use this one first, which is positive 3. It's plus 3, close brackets, open my next brackets, put x. And then I'll use this one, which is negative 4. Close brackets equal to 0. So now I'll say either x plus 3 is equal to 0 or x take away 4 is equal to 0. So transferring this positive 3 across the equal sign, the sign in front of it will change from positive to negative. And now 0 is nothing. So you'll simply get x is equal to negative 3. And on this side we have the negative 4, and we transfer it across the equal sign, and the sign in front of it will change from negative to positive. So we'll get x is equal to positive 4. So these are my critical values. And if I were to plot the graph of y is equal to x squared take away x take away 12, these would be the x-intercepts on the graph. So I have on the graph of y is equal to x squared take away x take away 12, the coordinate negative 3, 0, and that negative 3 comes from here, and the coordinate 4, 0, and this 4 comes from here, are the x-intercepts. Now a key point to note is that the coefficient of x squared is positive, therefore this graph would be a minimum curve. So here I have my x and y axis. I know my x-intercepts are negative 3 and positive 4. And I know this constant here on the quadratic, this negative 12, would be my y-intercept. So I'll go to my graph and plot my x-intercepts first. So I have negative 3 and positive 4. And also I'll have my y-intercept as negative 12. Again, this constant on your quadratic would be your y-intercept. And now remember that the coefficient of x squared is positive, meaning we have positive x squared. Therefore the graph would be a minimum curve, meaning it will come down like this. So now we'll make a sketch of the graph. Now notice that I have that y is equal to x squared take away x take away 12. So that means this would be represented by y, which would mean that y is less than 0. So if you look at our graph, this is the y-axis. Going up like this above the x-axis, y is more than 0, but below the x-axis, y is less than 0. Therefore, this region under the x-axis would satisfy this quadratic inequality where we have x squared take away x take away 12 is less than 0. Now notice as y goes less than 0, which is going down like this, notice the horizontal distance gets smaller as y decreases. See down here, it's a lot shorter than up here. So as y decreases, this horizontal distance gets shorter, which means the graph is closing in like this. So this would mean when y is less than 0, x is greater than this negative 3 here, but it is less than this 4 here. So basically x is between negative 3 and positive 4. So when x squared take away 12 is less than 0, x would be in between -3 and 4. So I'll write it like this. So this would mean x is greater than -3. As you can see here, going this way, x is greater than -3. And now x is less than 4. So it's going this way, x is less than 4. So this would be a solution to this quadratic inequality. So now in question 2, I have to solve x squared take away 12 is greater than 0. So the only difference between question 2 and question 1 is that in question 1 we had less than 0, and in question 2 now I have greater than 0. So the critical values would be the same. So to find the critical values, we'll let the quadratic be equal to 0. So we already solved the quadratic here, so we know the answers will be x is equal to -3 or x is equal to 4. So we'll plot the same graph of y is equal to x squared take away 12, where x equal -3 and x equal +4 are the x-intercepts, and -12 would be our y-intercept. And the graph would be a minimum curve because the coefficient of x squared is positive. So here we have the same graph as question 1. The only difference is that this part here is equal to y, and we'll have y is greater than 0. So y being greater than 0 will be above the x-axis. So we can clearly see that as y is increasing going this way, the graph is getting wider, meaning the horizontal distance is getting wider as we go upwards. Therefore, the graph is moving out like this. So we'll have when y is greater than 0, we'll have x is less than -3 or x is greater than +4. So I have when x squared take away 12, which is y, is greater than 0, we'll have x is less than -3 or x is greater than +4. So this would be a solution for this quadratic inequality. In this question, we have to solve the quadratic inequality -x squared take away 3x plus 10 is less than or equal to 0. Now notice that the coefficient of x squared is negative. That's because we have -x squared. So when we plot the quadratic curve, we'll have a maximum curve. So once again, to find the critical values, I'll let my quadratic be equal to 0. So now I'll solve the quadratic equation. So I'll obtain my product by multiplying the first term by the last term. So -x squared by +10 will give -10x squared. My sum would be the middle term, which is -3x. And my factors of 10 will be 10 by 1 and 5 by 2. Now the only one of these that can give 3 will be 5 and 2. So if you want to get -3, we'll say 2 take away 5. So therefore I'll write 2x take away 5x will be equal to -3x. So I'll be replacing this -3 here with +2x take away 5x. So I'll have -x squared plus 2x take away 5x plus 10 is equal to 0. So now I'll look at the first two terms, and this first term here have a negative sign in front of it, so my highest common factor would have a negative sign in front of it. So I'll look to see what's the highest thing that can go into these two terms, and that would be x. So my highest common factor is -x. So I'll open brackets, and I'll say -x squared divided by x, and I'll get +x. Then I'll say +2x divided by -x, and I'll get -2. So I'll close brackets. Next, I'll look at these two terms here, and again, the first term here has a negative sign in front of it, so my highest common factor would have a negative sign in front of it. So now I'll look to see what's the highest thing that can go into these two terms, and that will be 5. So my highest common factor will be -5. So I'll open brackets. And say negative 5x divided by negative 5, and I'll get x. Then I'll say positive 10 divided by negative 5, and I'll get negative 2. Now I'll close brackets and put that equal to 0. So now I'll take what's outside the brackets, the negative x and the negative 5, and I'll put that in brackets. And then these two brackets that are the same, I'll write it once. So I'll have x take away 2 is equal to 0. So now I'll say either negative x take away 5 is equal to 0, or x take away 2 is equal to 0. So I'll solve this equation first. Now what I can do is just transfer this negative x across the equal sign. I will change to positive x. So I'll have negative 5 is equal to positive x. So that'll just mean that x is equal to negative 5. And here I can transfer this negative 2 across the equal sign. I will change to positive 2. So I'll have x is equal to positive 2. So x equal to negative 5 and x equal to positive 2 would be my x-intercepts on the quadratic curve. And this constant positive 10 would be my y-intercept. And again, the coefficient of x squared is negative, so the curve would be a maximum curve. So here I have my x and y axis. So now I'll plot my x-intercepts, which will be negative 5 and 2. So that'll be here, negative 5 and positive 2. And my y-intercept will be positive 10. So positive 10 will be up here on the y-axis. So now I'll make a maximum curve connecting those points. So here I have my maximum curve of y is equal to negative x squared take away 3x plus 10. So in this question, this negative x squared take away 3x plus 10 would be y. So what we are saying is y is less than or equal to 0. So that will be the portion of the graph that's under the x-axis. Now you can see as y decreases, this horizontal distance keeps getting wider. So the graph moves outward like this. So when y is less than or equal to 0, x is less than or equal to negative 5, or x is greater than or equal to positive 2. So we have when negative x squared take away 3x plus 10 is less than or equal to 0, x is less than or equal to negative 5, or x is greater than or equal to positive 2. So this would be our answer to this quadratic inequality.